So with the one proportion z-test, what do we have? The one proportion z-test is for categorical variables. Think about it right now. What could we test? I say things like, let's test the proportion of students who like Taco Bell. You'd have to walk up to someone and say, do you like Taco Bell? And that answer should definitely be yes. Do you drink Red Bull? That's a categorical question right there. Categorical questions are things that are answered like yes, no, or true, false. Those put things into categories, and we just want to figure out the proportion of a certain level. So now that we know when to use the one proportion z-test, it's when we ask one question and we want to figure out the true proportion of that level. We're going to test the true proportion. We need to maybe look at the notation for this. Let's look at the notation for this question. So let's hop right over here. It's got the drawing up. Is that not the drawing? What is going on? Let's click the chat thing. There we go. I don't know what was going on with that. Okay. Notation for this problem. We're going to try to put all the notes here for all of these. I'm probably going to have to draw out the notation. It's going to be easier to do. So what do we have here? That's going to be easy enough. For the notation for this test, we will have n. What is n equal to? What is n equal to for notation for this? N will be equal to the what? This will be an easy one. We'll always do this one. N will be what? Let's see in the chat. N will be sample size. N is always sample size. And then we also have for this one P naught. P naught. P naught is equal to the hypothesized true proportion. You'll notice a theme if you're watching other videos in this. P naught is the hypothesized true proportion, so mu naught would be the hypothesized true mean when we get to another test a little later on. So P naught is the hypothesized true proportion. We also have Q naught. I guess we should mention that if people sometimes wonder what Q naught is. Q naught is the complement, and I'm just trying to remember, complement with an E, I believe, complement of true proportion. And if P naught, so it's just 1 minus P naught. That's what we mean by complement. It just adds to 1, so there is P naught and there is Q naught. That's how they are found. Last but not least, I'm just thinking through the equation in my head, we have P hat. So we got to go up here to the equation builder to throw a P hat in there. I guess we could draw it, but what fun is that when we can go to equation builder? Under equation builder, we can insert a accent. You got to bend down and see where it's at. There's the hat. We found it. So we got here P hat. We'll not need Q hat, we'll just use P hat because this one will just deal with the sample proportion. P hat is the sample proportion. Basically, I want you to know how to use every one of these tests, and that's why I'm coming in here to review this today. Here is all your notation for this one. You should know all of these and know how to identify them in problems. Now that we have this written out right here, we need an example problem. Let's do an example problem. Example problem. This is going to be a very, very quick problem. So we're just kind of giving a very, very short example problem for you to kind of figure out how to do it. And I want to ask you this. If you can write fake problems like I'm writing right now, not really fake, but just any problem, if you can do that, you understand how this works. And when you get to the test, that's all we do. I just sit around writing problems. That's all I do with my whole life. No, not really. But if you can write problems out, then you're doing what we're doing for the test. The better you can come up with problems, the better you understand what we're asking you to do on the test. So let's try writing our own problem right now. Well, all we need to do is come up with a problem. UT takes a sample, there we go, of 200 students. From this sample, 130 of them, 120 of them, 120 of the students believe we will go to a bowl game. Is there evidence to suggest that the true proportion of students who think we will go to a bowl game is greater than 50%? There you go, or 0.50, it's 50% too. Boom, we got our example problem. So now we have everything we need. I will add one more thing into the notation. I'm often asked this. We have right here, P hat is the formula of x over n. So let's go here and insert this. People often forget this, and this is a video I want everyone to see. So I want to put in every bit of notation I can do. P hat is equal to x, oh not s, or x over n. And so that is what we have going on right here. P hat is equal to x over n. And what is x? Someone might be saying, what is x? it's lowercase x, number of successes in the sample. So immediately you should start identifying things in this problem. Can anyone tell me, if you're in the chat right now, I know there's not a ton, but we should have n, we should have p naught, we should have q naught, we should have p hat, we should have x, we should have n, and again, all these great things right here are in this problem right here, right now. Let's see, and then this is what I would do on the test. I would take out my pen, choose a nice blue pen right here, and I would say, okay, the sample size is 200. That is n. I've identified n. This is how many successes there were, how many people reported the thing we want. There was 120 students who said, yes, we will go to a bowl game. This right here is P naught, and that makes Q naught equal to 0.50. P naught and Q naughts are just complements of each other, so when we know P naught, we know Q naught by just subtracting P naught from 1, because it has to be if it's 0.5, Q naught is 0.5. And I think that does everything except for P hat. P hat would be 120 over 200, so P hat is 0.60. Is that blocking me? Oh, it's right in the way of my head. So that is where we are at. So all I did was take x over n. X was 120. Nice job, Morgan, in the chat. Great job. So yes, that is what we have going on right here. We've identified everything for this problem. From here, let's go grab our sheet. So we've got our 4 steps to doing a test. Let's try it out. Remember, we talked about this at the start of the lecture, or the start of the little test thing today that we're doing. We're going to go down here to the end of it. We're going to put it right here. Write out the null and alternative hypothesis. So we need to write out our null and alternative hypothesis. You'll notice in this problem, I'm asking you, is there evidence? Is there evidence, okay, that sounds like I'm talking about an alternative, that the true proportion of students who think we'll go to a bowl game is greater than this amount. So I guess one more bit of notation, I hope it moves it down. This won't, I don't want to confuse you. P is the true proportion. We won't use P in the calculations because we don't know what P is. But the true proportion is P. We don't know what P is. That's what we're going to test. We're seeing if there's evidence that the true proportion is likely greater than this. We're going to see if there's evidence for that claim. So we're going to set up our test to see if is there evidence that the true proportion of students who think we'll go to a bowl game is greater than 50%. So what we have here is all of these values, identifying them, knowing in the in notation. I know there's P hat, I know there's P naught, I know there's P and P value. It can get very confusing. Take your notes and make sure you know which one each of these are. So definitely notation is the key to passing the test. So now that we're here to step 1, write out the null and alternative hypothesis. We just read it off. The null would be the equal sign. HO. The null states that the true proportion is equal to 50%. If you notice the question said, is there evidence that the true proportion is greater than 50%? I always ask my students to read this because here's the mistake I see on the test. I usually see this mistake. Read it now. It says the null states equals 50%. What equals 50%? What equals 50%? I see that mistake all the time on the test. And I say, read it. And it's like, okay, the null says it's equal to 50. What is equal to 50? The true proportion is equal to 50. Make sure you use the right thing right there. I'll often see things like people will put right there mu, but think we're asking students, oftentimes if you see a decimal, it's probably P, but probably, I can't say for sure it is, but we're asking students, do you think we'll go to a bowl game? So that would be not mu, it would be P, because this is the true proportion of students who think we will go to a bowl game. The null says it's equal to 50. We are looking for evidence for the alternative that it is greater than 50. So that is step 1. Write your null, write your alternative. Perform the calculation for the t or the z. So when we perform this calculation for the t or for the z, we need to choose the right equation. And so let's write out that equation right here, really nice and really big. And so I'm going to put it in the equation builder because that's going to be the easiest and best way for us to see it. So let's go to Insert, Equation. It's going to be z equals, and you do get a formula sheet for our tests. So do not fear, you will have a formula sheet. And we will have the equation written here in just 1 second. This one also needs that. And this will be, we need a p hat to start it. So it's observation minus mean over standard deviation, but it's a little more interesting than that. We observe a sample proportion, and then the mean of the null distribution would be P naught, so we need a little accent, or we need a little subscript on that. We need a P naught right there. Now we're going to take and we're going to copy paste our P naught, because we're going to use that down in the bottom one right here. Because right now P naught is assumed to be, you're welcome Morgan, thank you guys, I'm glad you guys are enjoying this review. P naught times Q naught, so I typed a Q right there. P naught times Q naught over N square root. So yeah, definitely come back and watch it. I want this to be here to help, that's why I'm doing it before the break, just so you can see all the different tests and how to do them. So we'll probably be going for like an hour more, but I want you to see how to do each test and when you use each test. So this is the equation, and we have all these numbers. So if you notice, we can just take our numbers from previous, and let's just drop them in right here. If you remember previously, you might have to scroll back up, but we said the sample proportion was equal to 60%. Turn the ringer off for the moment. The sample proportion was equal to 60%. Now let's copy the equation and do it. Watch this. Let's go here. Let's copy the equation. And so let's hit tab, makes it smaller. And tab again. Let's bring it back to this line right here. There we go. Tab it over. Try to make this look all nice and pretty. And we make it nice and big. So I'm going to write one of these right here with the numbers and one of them without. And there we go. So if you notice this one right here is the standard equation, then this one over here we're going to solve for z. So p hat was the sample proportion, which was 60%. Oy vey. That is too big. Let's go a tiny bit smaller. There we go. Okay, that'll work for now. This is the hypothesized proportion because it's P naught. You can look over there at the left on which one I'm doing. And then we need on the bottom P naught times Q naught. Be careful. This is where people often make a mistake because they often use P hat down here. That is P naught because according to the null, P naught is equal to P. This is P naught. P naught is 0.5. We're saying that is equal to P according to the null. So down here on the bottom, we're basically putting P because right now we think P naught is P. So if you remember P times Q over N square root, we're just doing that. Sample size 200. That's got it. Solve the equation and you've got the Z. We'll talk about conditions here in a moment, but the Z score is simply going to be solving the equation. So as long as I don't make a math error, we'll be good today. P times Q, or P naught times Q naught, over N square root. We're going to hit that square root button. That is now the standard deviation. So I just solved the bottom of the equation. Everything you're seeing right over there, where my finger's pointing, this finger, up, there we go. That bottom of the equation right over there is the answer, 0.035. That is the bottom of the equation. If you notice, the top of the equation is going to give us a positive z-score because it's 60 minus 50. So all we're going to do is do 0.60 minus 0.50. That's the top of the equation. We're going to divide this and get a z-score of about 2.7 or 2.8, 2.8 something. There we go. That is our z-score. Z-score found. Let's go ahead and round it to 3 decimal places. Usually we like 2 decimal place accuracy on the test. And let's double check to make sure we didn't make an error on our just transcribing of it. We're good. So you can double check your math. That's where a lot of mistakes can happen. We try to do contingent grading on the test, but we've now found the z-score. This is a z-score, and it's a test statistic, which tells us how many standard deviations away the observation was from the mean. I want you to look at this equation. All it is, when you're doing this, let's hop outside the equation builder. All it is the top part is a difference. That's just how far are those numbers away. And the bottom part of it is a standard deviation. So it's a difference standardized. A difference standardized is a z-score. Just like observation minus mean over standard deviation is how many standard deviations is the observation away from the mean. Now we're just figuring out how far away is the sample proportion from the null proportion. That is the top of the equation. How far is the sample proportion from our null proportion? And then what happens when we standardize that difference to turn it into something we can use as a z-score? So that's all we're doing here, and the answer is 2.82. And you should think to yourself, that's kind of large. That's kind of maybe a smaller p-value, because the larger the z or the t or the chi-squared, the smaller the p-value. And when we say larger, at least for z and t, we're talking absolute value, because it'd be further away. Like if I'm the center of the curve right now, if I'm a normal curve, the further away you go out, the smaller the p-value would be. But anyone else? Yes! Yes, Nicole, so glad to hear that. Yes, this is used throughout all disciplines. Confidence intervals, all this stuff, it's so commonly used. So glad to hear that. Thank you, Nicole. Statistics is throughout all disciplines. And you're probably like, I know how to interpret that. I'm 95% confident the true proportion of animals that will be affected by a certain illness is contained in the confidence interval blank to blank. It's the true proportion of animals that will be affected by an illness. Yeah. Or you could say on average this many animals are affected. So you could figure out how many animals are affected on average in a certain month. All that great stuff right there if you're calculating the average amount of animals affected or the proportion of animals that'll be affected. Because is an animal affected is a categorical variable, which we're doing here. And then if you collect data on maybe how many animals will be affected per 1,000, then you could collect data on that. Oh, that's so, man, I love hearing that. I love hearing that you guys are using this in other classes. Statistics is the backbone of a lot of disciplines. Anything related to science is using statistics, so we're all about that. Last drop of Red Bull. Okay, thank you, Nicole. So glad to hear that. I love it when you guys are using this in your discipline. That's what really makes me happy. All we gotta do is find that p-value now. So to find that p-value, we need to shade according to our alternative. Well, okay, so I gotta shade according to my alternative. So on the test, here's what we'd probably have you do. What you would need to do is draw out your distribution. And then you need to go here. I'm going to put 0, 1, 2, 3, 1, 2, 3. 1, 2, 3, negative 1, negative 2, negative 3. Then where did I land with my z-score? My z-score, and you'll see this in our jump output, we will see 2.828. There it is right there. That's where I landed. And now, which way am I going to shade? Which way am I going to shade? If you don't remember and you're like, well, how do I know which way to shade? Go right here and look at your alternative. That is a greater than alternative. What way does that point? It points this way. I'm mirrored right now. It points that way. So since it points that way, that's the way I'm going to shade. And that is my p-value. Now I want you to think, if we had landed closer to the null, if we had landed all the way over here, the p-value would be water. Usually in class we'll have a lot of people answering, but I'll tell you the answer. The p-value would be bigger. It's like you would just take that line, here's the line, you're going to move that line further over here and there'll be more shading under the curve, telling you that what you observed was more probable given the null is true. But what we observed, at least by what we're seeing right here, looks to be what? Probable or not so probable given the null is true. Does it look to be probable or not so probable? And the answer is, ours does not look to be that probable given the null is true. And I think this p-value is going to be very small. We'll show it here in a half second. Let me go up to here and let me pull down the David M. Lane normal curve. You know what? I'm going to go stat distributions again. Stat distributions, want to give them a big shout out, not that my shout outs matter, but stat distributions has a great site. And so let's take a look at the stat distribution site because they really do a good job on it. Okay, so if you remember my z-score, I'm going to go here and I'm going to put in my z-value of 2.828. And then I'm going to move out of the way just slightly here. We're going to go to right-tailed test. If you look at my p-value, I'm going to stand over here. There we go, works perfectly now. My p-value is 0.002. So that is a very low p-value. So with this low p-value right here, and if you look, does this look a lot like the curve I was drawing in Word? It should. That's my goal. What I was trying to do is draw out the curve right here and then do the same thing. Because we often have people say, wait a minute, how can I do that on the test? Well, you can draw it out. And we try to make it more obvious on the test. We try to make things like this where the p-value is going to be very small because we do know that if we're doing a right-tailed test, hypothetically speaking, if we were to land right here, hypothetically, if you were to land right at 2 and you were to shade above 2, what would be the p-value then? If you landed at 2, the p-value for that area would be about 0.025. The p-value would be about 0.025. And why? Because the 95% confidence rule. 95 is between -2 and +2, and I'll reverse time here in a second on this. But with 95% between here, that would leave 2.5% outside of either side on the empirical rule. So that p-value would be 0.025. So we can give you test questions like this, where we might say, do you reject the null at the 0.05 alpha? Although you can't for 100% know the p-value, at least theoretically speaking, the p-value has to definitely be below 0.05 because we are further over. If you look where we're at, we're further over than here, and from where I just drew, from there over would be a p-value of about 0.025. So we're definitely able to reject the null here, and that's where I was going with this. That's kind of cool. We got to reject the null, but now we have the p-value. We know the p-value, and we can see it on the previous applet. That p-value, I believe, was 0.002. That's telling us that our result of 60% or more extreme would occur 0.002 or 0.2% of the time, if we turn it to a percentage, 0.2% of the time, given that the true proportion is 50%. So given that the true proportion is 50%, our result of 60%, which has a z-score of this, would occur only about 0.2% of the time due to random chance variation. And think about that. That means the result is likely or unlikely given the null is true. Our result, look at the p-value, likely or unlikely. It's like, this is the probability you'll win the lottery. I mean, that'd be awesome if it was lottery. But you would say it seems likely or unlikely. This right here would be likely or unlikely given the null is true. And the answer is, it's not likely given the null is true. So when the p-value is low, reject the null. Last but not least, let's do it. Here's what we got to write out. We need to write things like, in this one especially, I reject the null hypothesis that the true proportion of students who think we will win a bowl game is 0.50. I have evidence that the true proportion of students who think we will win a bowl game is greater than 0.50. If you want to be specific, you could say my p-value is this. My p-value was 0.002, which is less than alpha, can't spell today, of 0.05. So this seems like I wrote a lot, but I want to tell you how easy it is to remember this. Let's go back to our null and alternative. Here's how you do it. When you look at your conclusion, I just want you to talk like this. I want you to go before the null and just say, I reject. I have evidence. So let's take a look at this. I reject the null hypothesis that the true proportion of students who think we will win a bowl game is equal to 50%. I have evidence for the alternative hypothesis that the true proportion of students who think we will win a bowl game is greater than 50%. Do you see how I'm just rereading the null and alternative, but as a sentence? I could summarize this to say, well, it looks like there's good reason to believe that more than 50% of students believe we will win a bowl game. I could summarize it like that because the null was unlikely. I rejected that null. Now, there is another option where we could say I do not reject the null, or i.e. fail to reject the null. Maybe we'll do that for the next one. I'll set up a fail to reject the null for the next one. But in this one, our p-value was low, and when the p-value is low, you reject the null. When the p-value is high, just let it fly. And what do I mean by when the p-value is low, reject the null? When the p-value is lower than your value of alpha, which is what we saw down here. My p-value was lower than alpha, which is 0.05. So if this p-value right here is lower than assumed alpha of 0.05, with a p-value of 0.002, which is lower than alpha, I reject the null. If my p-value had been high, what do I mean by let it fly? Let's say I landed right here. Does anyone have any idea what the p-value would be for this test? Well, look. You can probably see it now. Now the p-value for this test would be what? If you look at that test, if that had happened, I would have saw in my sample 50% because my z-score would be 0. So what would we say here? My p-value, well, that's half the curve, is equal to this. My z-score would equal to 0 because it would be 50% minus 50% or 0.50 minus 0.50, and that's a difference of 0. And thus, we landed right on the null, so there's no difference. And so does that seem likely given the null is true? If 50% of students think we'll win a bowl game, the most likely thing to see in a sample would be 50%. We're shading to the right because this is greater than test, and so what would we say here? We would change and we would say, I fail to reject the null We don't have reason to believe that more than 50% of students think we will win a bowl game. All I'm doing is reading that null and alternative again. I don't have evidence that greater than 50% of students think we will win a bowl game because I do not reject the null. I fail to reject the null. I hope. Is anyone in the chat? How we do in chat? Did that help maybe better explain where all these p-values and everything is coming from? I'm going to set it back up nice and neat right here so we can see what's going on. But that is your one proportion z-test.